terms to eliminate. Well, if I make xt and yt, that's t squared, right? If I make y, right? If I make z, if I make them all t's, right? X, y, and z, t, then I'm going to get a t squared here, right? I'll get a t squared here, and I get a t squared here. You see that? So I'm trying to make this happen, because these are already squared, right? So I'll make x, y, and z t's. It'll be t squareds down here, right? And I can add them together. See that? Which means that'll work, because if I make x and y and z t, these will be up here t squares as well. And I can add them together. Does that make sense? So you pick your t to a certain power that's going to make all these, to make them where you can add them all the like terms together. And add all the like terms together, you should have the same power in the numerator and the same power in the denominator for your t. Does that make sense? Okay? All right. So if I make x equal t, y equal t, z equal t. Okay? And what am I doing when I'm doing that? I'm traveling. When I'm doing this, I'm traveling. Okay? On the surface. Along that 3D curve, okay? That's what you're doing. All right, so therefore I have the limit. Since everything is going to t, right? These are all going to t. That means I'm traveling to, that means t is going to 0 because they're all going to 0. So t is going to 0. Make sense? All right? So therefore the limit as t goes to what? 0. It's going to be t times t plus t times t plus t times t, all divided by t squared plus t squared plus t squared. Right? So I got t squared plus t squared plus t squared is 3t squared. Same thing down here, right, guys? 3t squared. And what do I get? See? You see the process? And so I chose that path along the x-axis. I got a limit of 0, right? And then I did this, right, along the curve, making x and y and z to be t. So I can create this to happen, right? And found out the limit equals 1. See? And because 0 does not equal to 1, right? The limit does not exist at 0, 0, 0. Make sense? We all think, class, does this make sense? Yeah? Now take some thinking, okay? I mean, you gotta think, okay? Especially for that t part, right? Okay, you gotta say, okay, look, what makes it easy is look at your higher powers. Okay? Look at the highest powers, okay? Make t squared then. I want to make t squares. So what can I plug into these x, y's, and z's to make that happen? To make t squared? Well, make them all t's, right? I get t squares. See that? Okay. I think this one will be this next example will probably bring it home to you guys, okay? I think this will make more sense. After I do this, when it'll make more sense to you guys. All right, same thing. We have we're looking at this is a 4-dimensional curve, okay? The domain's 3-dimensional, right? Okay? All right. So we do the same thing, okay? First step is along the, pick an axis, right, that you want to travel along, okay? So if I do along the x-axis, and I'm going, okay, and I'm traveling to the same point, right at the origin, 0, 0, 0, along the x-axis. That means the limit as x goes to 0, which means I'm just making z, y, and what? Z and y 0, right? That means I get 0 on top, right? So it's going to be 0 divided by x squared. If I make all x 0, y, 0, y. Y and z 0, okay? And 0 divided by x squared is what? 0. Okay? Now we pick along the curve, okay? We'll say along capital C, along the curve. All right? Now we got to pick our x, y's, now our x, y's, and z to be a certain parameter, okay?
I was going to say, you could be along the y-axis, it's not going to work. If I want to make sure it's in the middle, like that.
Yeah, okay, if it doesn't work right, because you get what?
2y's covered, 2y's covered, which is 1.
Which is 1, right? Yeah. Yeah. You get a limit of 1, right? You can use that. You get a limit of 1.
Right.
And then you go find another limit. So you won't get 0, you'll get a limit of 1. You make x and z 0, right? Yeah. See that, Clint? So whatever. So you can pick any axis along you want to travel. Z, x, y. Okay? It's not always going to get 0, right? In that case, if I go along y, it'll give you a 1.
And because the two are not equal, you can see it doesn't exist, right?
You could do that. You could do that. You could, but that's not. But here's the thing: it's a 3D. I'm trying to. Okay, right. Well, watch this. Okay, so if I go along C, right? Okay, and I'm going to use the parametric T. Okay, because if you do the Y, then you have to do. If you do the Y, then you have to do the Z separately. You know what I'm saying? You got to look at. See, you got to look at all three. You got to look at all three. You just can't look at just. I know what you mean. You look at one and okay, that, but still you got to look at Z. You got to look at show all three. And the best way to show all three is make the parameter be what? T. Does that make sense? I know what you mean. Yeah, I know what you mean. Okay, so haven't said all that. What you do is okay. You look at your X, Y, and Z. All right. Which term has the higher power?
Z.
Z, right? Z has the higher power. Okay. So then you ask yourself, okay, since Z has the higher power, what happens if I make Z equal to T? And I create T to the 4th power. You see how I went to the higher power? I said, make that T. Okay? Make that my T. If I make that my T, Z my T, that's T to the 4th. Okay. Then what do I need to make X and Y to get T to the 4th out of them?
T squared.
Exactly. If I make X equals T squared, right? And Y equals T squared, it will work. See that? So always go look at the variable with the highest power and call that your T. That's a little trick to do that, okay? And by doing that, you have the limit as T goes to 0. Okay, it's going to be T squared times T squared plus 2 times T to the 4th, all divided by T to the 4th plus 2 times T to the 4th plus T to the 4th. Okay. So that's going to give me 4 T to the 4th on top, right? No, 3 T to the 4th on top. Okay? And the bottom, it's going to give me 1, 2, that's 3 plus 1 is 4. 4 T to the 4th. It gives me what? 3/4. Okay? Since 0 does not equal to 3/4, the limit does not exist at that point that I'm approaching, okay? 0, 0, 0. See that? Questions? Comments? Concerns? Man, I've got another weekend coming, man. It's like Wednesday to Thursday. Well, some of you have to work, might not feel that way. At least you don't have to come over here, right? Come to school. That's why when you go to work, be wise, say, I got school all week. No, don't do that. Don't be lying.
Yeah.
Don't be lying. I don't want you to be a liar. Don't be a liar. I'm just kidding. I couldn't do that. I go against my conscience, man.
Doesn't work for someone else anymore.
All right. Prove that the function does not exist. Okay, so here's an example. All right, another example. What's the first thing that you should do? Plug it. Yeah.
Choose one.
Well, plug in. Oh, before you do anything, plug in the point. Plug in the point and see what you get. Right? Direct substitution. Okay. Do that first. And if I do that, it's going to be 3 times 1 times negative 2 divided by 2 times 1 squared minus negative 2 squared. Okay? That's going to give me a minus 2. And gives me a positive 3. I'm done. There's my answer. That means the limit exists and the limit is 3. For all infinite paths. See that? So that's how you know a limit exists, because you get an answer, you get a number. Let's think about it. Yeah. Go back to Cal 1, right? Gosh, man, I want to spend 30 minutes on this, but go back to Cal 1. You remember when you had indeterminate forms, right? What did we do? We had an indeterminate form. F of x had an indeterminate form. What did you do? You went to go find a g sub x, right? Yeah. Okay? You changed the form, right, into a g sub x, right? In other words, you remove the whole. You remove the what? The isotope. You remove whatever's causing that indeterminate form to find the limit. Because remember, in one-dimensional, right, the limit still exists even though you had a hole, right? Does that make sense? Right?
Yes.
Okay. Well, in this case over here, with these 3 dimensions, where in that path is that happening? I got to break somewhere. If you get 0 over 0, you got to break. You got to break somewhere in your paths. You know what I mean? It could be or it could be just a hole in your path, right? Somewhere. Somewhere is causing you for not to get a 0 over 0. You see what I mean? So that tells me automatically if I get an indeterminate form, right? Okay, then that right there, most of the time that tells us that the limit does not exist. Because somewhere along one of those veins, one of those paths, right? And I got a blockage, I got a break in the graph. And it infinitely many. That's too many to look at. See what I mean? How do you find that one break? Out of infinite paths. Does that make sense? Okay? That's very interesting. Anyway, I just throw that in there. Didn't cost you anything. Had a little conversation. Okay, what about this one? Oh yeah, this is interesting. Man. So what that last example that we just did, okay, the last example we just did. That just shows you that, because we've been just looking at how to prove that it does not exist, right? That's just real simple. You plug in the point, you get a number, it exists. Okay? That's how simple that is, all right? I don't have to show a lot of examples on that. You know, pretty simple, right? Straightforward. Now look at this one. I have this x cubed plus y cubed divided by x squared plus y squared, right? Okay. And we can go the same route like we did earlier. Actually, this is my domain's a 2-dimensional, right? Okay. What I want to teach you in this one is you can do this, okay? You can do this. Anytime you see an x squared and a y squared, like that. Now, if I plug in 0, 0, you get 0 over 0. Okay. But anytime you got x squared plus y squared, you can say that r squared is equal to x squared plus y squared. It's a different method. So if I see that, x squared plus y squared, I can go this route. I can say, I can do the trig route. Does that make sense? I can change all my x and y to sine and cosine. Okay? I can go from rectangle to, say again? Polar. I can go to polar. I can use polar coordinates then. All right? So I'm just showing you an example of that, okay? Same stuff, except, hey, look, if I see this going on, I can do this. I can say, hey, this is r squared equals x squared plus y squared. I can say x is equal to r cosine theta. I can use y is equal to r sine theta, all because I saw x squared plus y squared. I can do that. You can go that way, okay? Which means if that's the case, if I'm gonna make r squared equals x squared plus y squared, and next y goes to 0, 0, that means the limit r goes to 0, okay? Right? Okay, of course, now, am I going 0 to the left or to the right here? To the right, because that's an r squared, right? Okay, looking at your positive values, right? And so if I do that, then what happens? This becomes an r cubed, cosine cubed theta. This becomes an r cubed, sine cubed theta. All divided by r squared, okay? Now this r cubed, right? I can factor out, right? And then this r squared cancels out with 2 of these, gives me just 1, right? So I have a limit. Okay, as r goes to 0, r of cosine squared theta plus sine theta. That's the square of cube theta, right? And if r goes to 0, right, 0 to the right, then it's always going to go to what? 0 here. Okay? See that? So my limit is 0. Okay? My limit is 0. And again, remember,